Hello, hello. Welcome, everybody. This is the Ava Meet and Learn for the Ava platform. And it's a webinar we're doing here to get you started with the Ava platform so you can kind of understand what we're doing, what Ava is a little, and how you can integrate this, start integrating this into your applications and start playing around with the platform prior to mainnet. So this is our second webinar of this same series. We did one earlier today and went along swimmingly. So this should be great, guys. So everybody say hi. There's a chat channel in the Crowdcast app. Go ahead and say hi. It's nice to know that you're there. If you have any questions, don't be afraid to, oh, Gatsby. I don't like that comparison. I don't like that comparison. It's not that bad though. The chat window right there. If you have any questions, try to interject. I'm going to be moving through this material really at a steady pace. But if I see something that catches my eye, I'll try to address it immediately. The entire intent of this is to get the audience, you guys, really up and running with Ava, so that you feel comfortable installing the software and actually playing with the tools that we've set up. So without further ado, let's just kick this off. Let me start off by saying a bit about who I am. So my name is Collin Cusce. Yes, that's how you pronounce it. I'm a senior blockchain engineer at Ava Labs. I've been a developer since '99, and I got into the blockchain space around March 2017. That was right before the ICO boom, if you remember. I had been kind of interested in the space since early Ethereum. Got in very early on the Ethereum side, networked that way, and then really decided to jump in full time when I saw the network was gaining traction, and I really saw the potential in what was going on in that space. Since then, I've joined Ava Labs as of August 2019. The reasoning behind that is I have this podcast called Hashing It Out with my co-host Corey Petty, and it is on the Bitcoin Podcast Network. And we interview engineers in the space of decentralization, specifically focus on the tech, the design of decentralized protocols in general. And we had the white paper, Team Rocket white paper, come by just passed by my radar in May of 2018, and searched around to figure out who would be the best person to talk to about it. And Goon came on the program, and our CEO at Ava, Dr. Gunsur, and he talked about Ava with me and Corey about October 2018, and I wasn't quite sold. But we had him back on for the 50th episode, and by that time, I guess you could say the explanation had matured a bit, and I was definitely sold, and I saw that something was big there, and that it would work. So I had an inkling that it definitely would work, and so I decided to say, hey, I'd like to work with you, and I am fortunate, very fortunate, that he said yes, because this is a incredible protocol, and what we're doing here is pretty revolutionary in the field of decentralized permissionless consensus. So let's talk a little bit about what that means. So we're building a platform. It's a proof of stake consensus platform, and the real takeaway here is that it's a consensus platform, which is a big differentiator, I think, between, say, your Bitcoins and your Ethereums, where their data model, blockchain, is tied to their consensus model as a feature of Nakamoto-style consensus. So the blockchain is kind of essential for forming consensus around information. Well, Ava, that's completely decoupled, and that enables us to build an actual platform of blockchains. So where you could create any kind of data structure you want. Like we have a DAG data structure, we have blockchain data structures. Both of them operate under this Snow protocol family of consensus. And anybody can join the network and just participate using that consensus mechanism and deploy their own blockchains. You could create your own new assets, and you could create subnetworks of subnets of a subset of the overall validator sets in the system. So you can say, this is my friend, these are my friends, and they will validate these chains that I have. You can define those rules how you like. And you can build your own custom virtual machines. So you can create a data structure independent of blockchains and DAGs and all the traditional things we hear that is powered by consensus. And you can use that to maybe do, I don't know, log maintenance or something like that. There's a lot of interesting stuff you could do when you have that granular level of control over the data separate from the consensus mechanism. And of course, we have the ability to, the way this is built, to actually do cross-chain consensus. So you can take an asset and move it from one chain to another within the platform, and it will work atomically, and it is just as quick as normal transactions. So that's what Ava is, and let's get a little bit of why this is important and what's going on here. So there's a lot of terminology around consensus mechanism, but I really want to focus on some of the features that make Ava more, like it's 2 orders of magnitude better than what's currently out there. So the thing about the main measurement that people typically have when they're talking about the scalability of a blockchain is throughput. And that's not the only measure, but it is probably the one that you hear the most. And with Bitcoin, you get a throughput of about 7 transactions per second. With Ethereum, 14. With Tendermint, about 1,000. I did ask the developers on Tendermint, approximate what would be a good number that wouldn't make you like balk, and they said 1,000. But with Ava, we're getting over 4,500, and that's a low estimate. I want to let you know. The reason I put that there is because we test on certain machines, and those certain machines get 4,500, but we test on better machines with a little more compute power, and they get higher. So we're kind of more tied to just regular compute power, and we don't use, by the way, no specialized hardware for this. So it's just AWS instances. Okay, so there's that. There's finality. Bitcoin takes about 60 minutes to feel confident that your transaction made it to the final blockchain, and with Ethereum, it's about 6 minutes. This is all because of confirmations and the way heaviest chain consensus works. You need to wait for 6 blocks to confirm your transaction before you will feel like your transaction is actually final. You see this in a lot of the exchanges. They'll have all these confirmations you have to wait for. Well, with Bitcoin, it's at least 6 for real strong confirmation. With Ethereum, it's about 25. Some say 20, 25. Either way, it's about 6 minutes, give or take. With Tendermint, it's 67 seconds of block time, which is pretty good. But with Ava, it's less than 3 seconds for global consensus to be reached on things typically. So you're looking at very, very fast finality that you can't see in other platforms. We are energy efficient. That is, a lot of that has to do with the proof of stake mechanism we use for Sybil protection. We have a safety threshold of we have a parametrized safety threshold. So in Bitcoin, you hear about in Ethereum, the 51% attack, like, oh, ETC got 51% attacked, that kind of thing. That is a feature of Nakamoto heaviest chain consensus. Tendermint follows a classical consensus model, so it's 33%. But mind you, that's 33% control of the stake of the validators. And with Ava, we are 80% parameterized. We can get that high and not really feel like we're sacrificing too much. Of course, there is a liveness trade-off. So every time you choose safety, there's a liveness trade-off. 80% would guarantee, I think, about 10% liveness. But that actually, in practical matters, might not be that big a deal, and we're pretty sure that's the case. But if it's not, it's parameterized, so we can trade it off so that we can make it something more reasonable. Either way, we're safety threshold is capable over 51%. With other protocols, you're pretty much fixed at what exactly that protocol specifies, and with us, we can tune it to whatever makes sense for the network. In fact, actually, interestingly enough, if you set all the variables equal to 1 that we use for this parameterization, it equals exactly 33%. So that's our tie to classical consensus. Is actually, that's how we kind of link the two back together. But yeah, no, we can actually do a parameterized trade-off here. And one of the interesting things is kind of there in the middle is the number of validators. Most transactions are validated by pools these days in the traditional heaviest chain systems, and there's about 13 pools on both networks who own a stake over 1% of the hash rate. That's what HR means, hash rate. So it really takes only like 3 or 4 phone calls to technically reverse a transaction. You just got to call the right people, maybe 4 or 5. And if they all agree, then any transaction can technically be reversed on any of these networks. On Tendermint, there is it's the same safety threshold, but you can only have like 200 validators. So it's 33% safety threshold, but you can only have 200 validators, which means basically you're capped at the amount of decentralization you can have in this network. And with Ava, we don't really have a cap. It scales, 01 amortized messages with the number of validators in the network. So we're not bound by any strong limit to the number of validators who can participate in the network and vote on validate transactions. There's no hash rate involved either, so we don't have to worry about people gaining the newest ASIC and suddenly having a lot more power or anything like that. We use regular compute models for everything that we do. Cool, and so let's talk a little bit about how this came about. There's a Team Rocket white paper that happened in May of 2018, and that's when it kind of hit my desk at least, and I was like, oh wow, this is super cool. Does this actually work? And it winds up being that it does. And the cool thing about the Avalanche paper that Team Rocket put out is that it really takes all the best features of Nakamoto consensus and all the best features of classical consensus and adds resilience to 51% attack on safety. And there's no major trade-off here. I was really, really skeptical when I first read this, like super skeptical. Like I said, the first time I talked to Goon, I didn't really come out of it 100% believing it. But it works. It just works. Like it actually works. The math works out. Practicality of it works out. It just does what it's supposed to do. So this is a huge leap forward in decentralized permissionless consensus because you can build networks of any size validators, and as long as you have a good Sybil mechanism in there, like we choose proof of stake, then you can have transactions run through at tremendous speeds. Visa on an average day does about 2,000 to 2,500 transactions. During peak Black Friday hours, they do about 5,500, and we can match that. So this is kind of the Visa level payment system that people have been looking for all these years, and add in the fact that we can add subnetworks on this that have their own value proposition and their own governance rules, and you're looking at the potential for payment systems to scale even differently than that. So you don't even have to do it off the main Ava network. You can create little mini subnetworks which have their own scaling properties, which could enable some really interesting things going forward. So all that said, enough talk. I'm not here to pitch on Ava exactly. There's plenty of material out there. We are open on our Discord to talk. I'm going to say that about 100 times. Please join our Discord to talk to us. We want to hear from you. We want you to work with us. But let me show you exactly how to get a local network running on your local system, on your local machine. We'll run a 4-node network, nothing fancy. We'll get a wallet going. We'll get a faucet going. We'll show a transaction going from the faucet to the wallet, and that'll open up. That'll basically take up enough time so that we can have, I can leave about 15 minutes for questions. We can go over on questions. I'm willing to stick around as long as you guys are to answer your questions. But I know the question portion is actually something that people really want. So I'm going to try and get through this material, which, by the way, is already up and live. And I'm going to do just a quick run through of what already exists, because it does help people to have that. But these articles, I'm literally taking these articles that I wrote, and I'm going to be walking through them quickly so you can see how it works and get a good mental model for what we're doing here. So to start, I'd like to, before I get into all of that, I'd like to point you guys to our GitHub. Our GitHub is located at github.com/ava-labs. And here you'll see some of the more important packages that we're going to be working with. The Gecko Client is the primary client for an Ava node. It is our Golang implementation of an Ava node. It is perfect. It's open source. We've released it to the public to do whatever they need to do with it. Please contribute, submit issues, and play with it. We really want your feedback, and we really want you to use it. So that's public. This is running the current Borealis release. We also have the Avash Ava shell client, which is what I use to automate some of the shell launching things. That's what I'm going to use to make the 4-node network. We'll be using that today. We'll also be using the wallet site repo and the faucet site repo. So all those will be used today, and you'll see those in action. So without further ado, I am going to switch to my terminal real briefly. And I need to move a window, one moment. And we are going to install the Ava platform Gecko Client. Oops. There we go. And get that running for live on the webinar. So to be clear, there are some requirements. We do assume Ubuntu 18.04. That's not a hard requirement. We've got it running on other Linux flavored operating systems, but for our testing purposes, we try and keep it to something we can manage, at least this early. So we're just all selecting Ubuntu 18.04 as the stablest, as the version of operating system that we prefer when we're troubleshooting this. We also have macOS Catalina, which is also an acceptable operating system at Catalina or greater. For the software, we use Go version 1.13. So that is a requirement. 1.14 currently does not work. We are fixing that, but right now it's 1.13 only. And then for the wallet and the faucet, we use Node 12.13. So those are the versions. These are long-term support versions. That's a long-term support version for Node. We try to stick to long-term support versions for our testing purposes. Okay, cool. So there's that. We also have a few operating system dependencies, which we require. So, curl, we need a compiler to build the software. We do need libssl dev, libuv dev, cmake, and make. So libssl and libuv are something that's already installed on the system. In fact, all of those are. So I don't need to actually run through that process, but these instructions are in the tutorial. So we should be good to go with that. Now, let's go ahead and install the actual Gecko node. So to install the Gecko node, we're going to, well, first off, let me show you something that's been kind of tripping some people up. When you do Go, you definitely want to make sure your Go path is set. So my Go path is set properly right now. If you're juggling multiple versions of Go, like many Go developers are, I recommend using GVM. It's really a handy tool. It's not something we personally support, but it's something I do find useful when juggling, switching between different environments, and that should automatically set the Go path for you. So definitely check out the GVM tool. Likewise, there's an NVM tool, which I use for node versioning as well. Both of those are super useful. Definitely look into them. They're very helpful for managing this dependency of the language has to be this version or that version or whatever. I've had that encountered a dozen times across different tools, not just ours. So it's useful to have that kind of ability. So I do endorse those personally, but that's not something that Ava necessarily requires. Okay. So to install the Go client, we're going to use the go get command, and this is the go get command that we use. The -d will press a particular. It'll just download the files without actually trying to compile them, and the -v will be verbose. So I'll just paste that command in and literally run it. So while this is downloading, I just want to let you know it is pulling down Go Ethereum. The reason for that is because our platform works. We have a X chain. The X chain is used for the Ava payments. It's running the Ava virtual machine, the AVM. We have a P chain, and the P chain is used for staking and yeah, basically just staking, running, validator synchronization, that kind of thing. And then we also have the C chain, and the C chain is running an EVM. So if you remember, if anybody knew from October, I think it was October, DevCon 5, Yoon went up and spoke about Ethereum. And Ethereum was a demonstration that we could take the Geth client and literally stick our consensus mechanism in and remove all the Nakamoto stuff and get it working. And we did. We built it in like 2.5 weeks. It was incredible how quickly that came together. And Ethereum is what's currently running the C chain on our system. So you can run Ethereum-based smart contracts right out of the box right now and just post in the C chain, and it should work just fine. So that's super cool. That's why we pulled down Go Ethereum. We're running. We're actually using it just as a tool that we can use the EVM on. So it's pretty cool. All right. So now I've pulled down the Gecko code. Let's go ahead and pop into the Gecko folder. So I'm going to hop in, and there I am. And let's look at the code that was pulled down. As you can see, it pulled down just fine. We're good to go. So all I need to do to get Gecko working is to run this script, the build script. And for that, we just type /scripts build.sh, hit enter, and it'll build Gecko right here in front of us. So this is also building the Salticidae library, which is something our co-founder Ted Yin. Ted Yin is a co-author on the Hot Stuff consensus protocol, which is what was going to power Facebook Libra. So Ted built Salticidae, and that's what's doing our peer-to-peer communication. This will compile all that. This should also work for Mac as well. So this is a pretty handy script, and as you can see, it happens pretty quickly. And if I go to the build directory, check, there you go. Ava's right there, and it just got created. So that's our. Did not mean to do that. That's fine. So go ahead and paste. There we go, and we're back. So that the executable just got built, and now we need to actually run some nodes. So the easiest tool that we have right now for getting you started from 0 to 1 really quickly, granted, you can manually launch nodes just in the terminal. There's nothing stopping you. In fact, all this is a wrapper around that. But it's really great because we can create like templated networks that you can deploy on the fly. Is this tool called Vash? So I'm gonna go ahead and get Vash right now. So I pull down Vash, and that's literally just pull down the repo. It's pretty straightforward. And I'm gonna move into the Vash directory. And as you can see, the files got pulled. And then to build Vash, all we do is say go build. And Vash is built. So Vash is, like I said, just kind of a shell environment. It's a wrapper around the ability to launch nodes. But we can also do things like write scripts, which enable us to create templates for node networks. And the script we're going to be launching today is the for node network .lua script, which is really handy for just getting a little mini network on your system up and running like immediately. Without having to know a whole lot about the parameters involved in launching the Gecko client right off the bat. So you can test it like right away. So let's just open up a Vash really quick. And Vash does have a configuration file, and it will try and create that file. And if nothing's in the file, it'll just go to the defaults. For right now, our defaults are sufficient. Don't need to do a whole lot. There are instructions in the tutorial on how to configure Vash a little further, but for the purpose of this, we don't really need to configure Vash anymore at all. So Vash is now working. We're good to go, and we want to show that we can run nodes on the network. So I'm going to go type run script, which is a command we have. Actually, let me just show you this. You type help. Here's a list of all the commands available in in a Vash. And if you do help, for instance, start node, it'll show you all the commands available for the actual start node command as well as their defaults. So Vash has kind of got a built-in help mechanism. It should be pretty self-documented, but we also have documentation online in our docs, which I'll show you a bit later. Okay, so let's just run a quick node network to show that working. And we'll just say scripts, and then I'll use that for node network.lua that I showed before. And the nodes should be launched. I type proc manager, list, and it'll list all the nodes that we brought into this network. So here's all the nodes that we just launched. You can see they have a name and their status is running. So let's take a look at the actual nodes themselves. Make sure that they're up, and there they are. There's 4 nodes that got launched, and they're ready and good to go. Cool thing about Vash is that it kind of partitions the databases for all these nodes. So your database for your N1 node doesn't conflict with your database for your N2 node. It'll put them all in their separate folders and have their own separate databases, which is really fantastic for testing. This 4-node network script is also really fantastic for repeated replicable tests. Every time if you do something like db, if you have db enabled equals false, then it won't even write to the disk. So next time you fire it up, it's like you have a totally clean network every time. Really great for automation, continuous integration, that kind of thing. So one other thing I want to show is that you can individually start and stop nodes. I'm going to stop N1. And you can see that it stopped. And if I go over here and do that same command, now there's only 3 nodes, 1, 2, 3 available. And then I could start it again if I wanted. And it starts the node again, and then we do another check, and look, 1, 2, 3, 4 nodes are now running again. So, and one other thing, it will clean up its environment when you exit. So if you type exit in Vash, it shuts down all the nodes, and then your whole environment's clean. So it does good housekeeping for itself as well, which is another reason why we use it. Okay, so Vash, we're going to go back in, run script, scripts for node network.lua. I didn't type that right. Scripts. There we go. Okay, and we are off to the races. So now that I have a 4-node network running locally on my machine, let's build the wallet and actually get the get something that you can see and immediately interact with going. So for the wallet, I'm going to go ahead and I'm just going to pull down the Git repo for the wallet that I showed you earlier through git clone. So I'll git clone the actual wallet site, pulls it down, and I'm going to move into that wallet site that I just pulled down. And then all I have to do is type npm install, and it'll install all the dependencies for this wallet site. So that takes a hot second, but it'll actually pull down the modules that it needs and all that stuff. So this wallet will run locally, and it enables you to interact with the nodes that are currently running on the network. It can be interfaced to remote networks as well, though. I would like to keep in mind that these are all beta, very, very new, and for test networks is fine. For main network, we're not hardened yet. I would not go that far at this point, but this is great for like local test network work, especially at this point. So, okay, so now that the wallet has been installed, we're going to need to set up a configuration file for this wallet. To do that, I'm going to copy the configuration that is in the example into a file called .env. So I'm cp.env.example into .env. Hit enter, and then I'm going to just take a peek at .env, which is our configuration, and these defaults actually are fine. So it'll use the IP of localhost, so it's your local machine doing all this. The Ava port, that's like kind of our de facto default like gRPC port. So that's fine. The Ava protocol, we're just going with HTTP for right now. That's all we need. And the network ID 12345, that's our default like test network ID. Like, why not? And our app chain is going to be the X chain. So we're interfacing directly with the Ava's X chain, which is the one that houses the Ava token, if you recall me saying. So, oops. So that should be all set up. And now all I need to do is do npm run serve, and the wallet will launch. Give it 1 second, though. It's got to build the modules. So this wallet is running locally, and because of that, it will not have SSL certificates or anything set up for it. So for our, just in this current state. So we do get a little bit of a warning, and I'm going to switch to the wallet window right now. When we first connect, that says your connection is not private. Just hit advanced, proceed to localhost unsafe. Cool. And here you go. It's a wallet. So we're going to create a new wallet, and this should be pretty straightforward. You can play with this app all you want on your local machine. There are a lot of features here, but for right now, we're just going to create a new wallet. To do that, it's going to generate a new private key pair, or new key pair with a private key. It'll ask you to copy your private key and back it up. And then we'll just access the wallet. Like I said, this is very early, but it does do the basic functionality we kind of need. So here we go, is the wallet site. There's no balance, of course, because there's nothing in it. It's just a new key, a new address, and here's your address right here. It's operating on the X chain, and you could copy it right there. Copy to clipboard. Cool. We also have something so you can manage your keys. We have some paper wallet functionality that you could use. You can even get your own camera, scan a paper wallet. You can export a wallet. You can import a wallet with a password. It's all kind of like basically kind of getting going right here. So this is a really cool wallet, basic example dApp that runs on the Ava network that you can launch today. Okay, so now that we have a wallet, let's pop back over to the faucet and, back to the terminal, and let's go ahead and create a faucet. So much like the wallet, the faucet is just a node program, and we're going to do exactly the same thing, pretty much the exact same steps, except we will need to modify the config file. So for the faucet, we're just going to git clone, pull down the code. We're going to cd into the faucet. See that everything pulled in. Do another npm install. And while that's installing, I'm going to go ahead and pop over to the browser window and show you kind of what we need to do. So the faucet, to prevent flooding, we have kind of by default a Recaptcha system. So we just require you to get a Recaptcha key. That's all. And to do that, just go ahead and hit this create box when you're on the Google Recaptcha site. The link is provided in the tutorial. Hit create. We're going to say this webinar test Recaptcha v2 at domain localhost accept, and that will provide us with a site key and a secret key. So those site keys and the secret key we're going to use right now. And I'm going to switch back to my terminal. And just as before, I'm going to copy the .env example into .env. And then I'm going to edit .env. And as you can see, there's two pieces of information that are missing here. The CAPTCHA secret and the CAPTCHA site key. So I'm going to go ahead and put that CAPTCHA secret in. And I'm going to go ahead and put the site key in. There we go. Verify I did that right. Yep. Okay, cool. There's one other thing I want to point out. The asset ID Ava says that we're using the Ava token. There's a private key already loaded with a ton of Ava in it, and it's this private key you see right here. This is the test key. So this test key will, on every network you deploy right now through this Borealis Genesis, will use this private key and have a bunch of Ava preloaded into it. One other thing I'd like to point out is this faucet measures everything in nano Ava. Ava works in has one Ava is 10 to the 9 nano Ava. So what we're going to do is actually make it be one Ava right now. So to do that, I'm just going to add 9 zeros after this one. 1, 2, 3, 4, 5, 6, 7, 8, 9. And now we'll be transferring one Ava per faucet transaction. So save the environment variable and do an npm run serve. And it will do the same thing that happened before with the wallet, where it's going to compile everything and pull down the modules and get it all working and get it running and going and all that stuff. So this is a pretty straightforward process for getting things running. I'm going to pop into the browser real quick. And similar to before, we're going to see this privacy error. Just hit advance and ignore it for the time being. And that'll pop us into the faucet. So I'm going to copy the address from the wallet into the faucet. It's literally all I need to do. And hit on, well, I also need to prove I'm not a robot. But that will send 1 10 to the 9 nano Ava to the wallet. So I'm going to go ahead and request that, and ta-da, it worked. On the actual terminal, you will see that transactions are going through. It should appear right there in the terminal. And I'm going to go ahead and do it again just to show you that it appears. Hit ta-da. Okay, cool. It'll show you the transaction ID and the address that it sent it to. It's handy to monitor that. So pop back over to the browser. And let's go ahead and send one more. Why not, right? Cool. All right, and then I go over to the Ava wallet, hit balance, and there's my Ava. So it is transferring through this network. There's a local network running on this machine. It's fully operational. Things are up and running, just aces. So this is the nuts to bolts of getting a essential Ava, a basic Ava network running on your local machine and sending transactions around using that. Okay, so I want to talk a little bit about some of the tools that are available in Ava as well, briefly. We do have a JavaScript library. It has a ton of functionality available to it. You should definitely check that out. I also want to point out that our docs are really, really, really comprehensive. So pop over here. There we go. So we have a really great doc site. It's got a quick start guide ready to get you going. It has some overviews of the system, has all the reference materials, all the way down to the transaction format of the network protocol. All of our APIs are completely documented. We really put a lot of time and care into this. These curl calls can be run on a command line right away, and will get you going as well. In fact, a lot of the slope stuff is just a wrapper around this, but I also have the ability to generate transactions locally and sign them locally, so you don't need to rely on any node's security model. So there's a lot of advantages there, but we have all sorts of APIs you can actually execute with. Here's the EVM C-chain API that I was discussing earlier, the platform API. We have some IPCs available, so I really encourage y'all to take a look at docs.ava.network. Also, I think it's important to point out the Ava Labs page. So we have a lot of resources available here as well. First off, definitely check out our Discord. I really want to encourage everybody here to join that Discord. Our developers are extremely active there. We're always trying to help you and answer your questions and get things going. It is our #1 priority to kind of service you and make sure that things are working for you. So please hop into our Discord, take a look around. We've got a lot of activity there. We also have the Developer Accelerator program, and if you click on the avalabs.org/DAP, we have all these tutorials that I referenced. They're right here in these 4 links. A link to our Discords right there as well, a link to our GitHub. And we are offering bounties for people to find security flaws in our system up to $50,000, depending on the severity of the bounty. So please check out the Developer Accelerator program. We are really hoping that to get a lot more traction through that. I think a lot of people have already been starting to dig into finding some code, some bugs. In fact, we left 4 bugs in there, so that we have like a hash of the file that describes the 4 bugs. So we're still waiting for people to find even those 4 bugs that are already in the code base that we kind of put in there intentionally, just so that you could have some. We knew you had something to discover, if that makes sense. So that's really cool. Check that out. I also suggest checking out our careers page. We have tons of positions open. We're looking for the right people. We definitely bias towards hiring local in New York City. But we are open to the right person if they are remote. If they really show exception, they are really exceptional. We do hire remote. We definitely do prefer people who are local to New York City. So definitely check out our career page. Pass that around. Okie dokie. So let's see. I guess with that, I'm open for the questions. So yeah. How's it going, guys? So what do you think of the Ava platform? What kind of questions do you have? And let me know what you think you would use this for. Tell me what your thoughts are at this point. Nobody? No questions? Man, the 8 a.m. one had tons of questions. No questions. All right. Well, the platform itself has, let me go over some of the features in the platform itself. We've got a architecture that enables you to build your own virtual machines within the platform. So we have some tutorials on actually building a basic virtual machine. I think that's really interesting to check out. A lot of the more premium use cases that we've seen depend on this virtual machine, the ability to build your own virtual machines on our system. And those virtual machines are what I said before would actually power the building your own blockchain or building your own DAG on the system. So this is something that I think you guys would really find interesting, and you can actually build your own right now that just by implementing this interface and going through this kind of stuff. You can mint your own assets on the Ava network as well. So you can create your own assets. You can specify certain parameters on them, and they will work in the actual AVM, and people can exchange them around like they would normal assets, or the default Ava token. Oh, got some questions. Cool. Is it possible to create private smart contracts? Define private. So I'm not really sure what you mean by private smart contracts. By definition, smart contracts tend to be open. What you can do is create a subnetwork, and that subnetwork can have privacy considerations that the main overarching platform subnetwork doesn't doesn't have. So you can have a subset of validators that maybe adhere to KYC or AML compliance. And if they don't adhere to that, then they cannot join that subnetwork. And then within that subnetwork, you can create a chain. And if people check off the right boxes and also have like maybe some certificate authority signing who they are, you could, in theory, build something that only allows for smart contracts that work or people to participate and even bootstrap that chain if they pass the overarching privacy requirements on the subnetwork. So I'm not sure what you mean by private smart contracts. The only kind of private smart contract I have ever seen is either on a private network, meaning that it had limited access and not everybody could just open and permissionally join it, which you can technically build through this. And the other one is like homomorphic encrypted smart contracts, which are really slow, very large, and I don't think they're practical. But the fact that you can launch your own VMs, I think, enables you to do a lot of things that you couldn't with a lot of other systems, and still lend the consensus mechanisms that we have already built into our platform. Do you think the community will be open to develop beyond DeFi much? Without question. So actually, let me reverse that a little bit. It really depends on what you consider DeFi. So with NFTs, if you have an asset on a system, is that a financial asset? Do we necessarily have to have value associated with that serialized thing? Or could it just be a fun asset? So I could see a lot of use cases where things don't actually have real tangible value outside of the ecosystem that they exist. For instance, video games. That could be a potential place where there's not necessarily DeFi. But from the generic kind of like perspective, I could see how somebody could argue that that's still financial. However, I also have seen things already form where people are using this consensus protocol to build more resilient systems for things like log management. And while there are better centralized systems for this, I think, in a decentralized context, I have not seen anything that could even come close to managing that. We do. So I think the Ava community is really onto something that might go outside of the DeFi world. But of course, traditionally, people look to these systems, they think DeFi, they think coins, they think tokens, they think value exchange. I don't think there's any limitation to the human's ability to come up with something cool. And I think things like the handshake protocol are very awesome, and seeing that inside Ava would be aces, because we could definitely the whole community can kind of benefit by having something like that in Ava. So is it true that nodes only do work if there are transactions? No creating empty blocks. Yes, that is true. So our network is quiescent. That means that if there's no work to be done, it won't do work. Part of that's a feature of the fact that we use proof of stake. The other part of it is just the way that the protocol works. It's it's got asynchronous qualities to it. So if there's no transactions coming to us to a node, it won't try and parse transactions. It won't try and validate them. Why would it? Meanwhile, it doesn't try and create no-op transactions just to keep things going. Well, for the most part, but it doesn't do like hardcore work like, for instance, Bitcoin does, which requires specialized hardware and really just grinds a bunch of numbers constantly. Our system scales with normal compute power. It does not require graphics cards. It does not require ASICs. And part of the reason it can do that is that it's quiescent. It doesn't require you to do hard work. So yeah, that's definitely true. Did you run a node on a Raspberry Pi? Specifically, I'm interested if POS worked through a Pi when main is out. So we have had somebody express interest in this and said they were getting it going, and they claim to have got it going on a Raspberry Pi. Internally, in the Ava community, I haven't seen anybody outside of him. So I don't think I could say for 100% certainty, but to me, there's absolutely nothing stopping it. Raspberry Pis are sufficient for running a Gecko node, with the right requirements. They're not memory intensive. It's not incredibly hard. The problem is that will a Raspberry Pi be able to keep up with a real network? I can't say until that real network actually exists, and even then, it really depends on how much load is actually on the network. So if the network is trying to push, 4,000 or 5,000 transactions per second through, I actually don't think I'd be very surprised if Raspberry Pi kept up with that. I wouldn't be surprised if a C5 large instance on AWS would, but Raspberry Pi, probably not. So the question is, how many transactions does the network need to sustain? It's a very kind of more wishy-washy, complicated answer, but I think for certain you can get a node running on a Raspberry Pi, no problem. Besides Ethereum, any other testnets you have run or plan on doing existing platforms chains? Thank you for the compliment on the great presentation. I'm trying. As far, we've done local VMs and test VMs all the time. We have not done anything like the EVM, the Geth importation, the Ethereum stuff for any other network. We don't really feel like that's something that we necessarily need to support out of the box. There's plenty of potential there. I mean, I know that BCH has been looking into switching to using Avalanche to improve their system already. In fact, one of the developers working on that has now joined our company. So I do believe that there's enough community out there, enough people interested in their own personal assets and their personal coins, that they can do that work. If they feel as though there's benefit to, say, making Grin available on the Ava network, by all means, like it's start today. Like, we're ready. You can get that going. But we ourselves are not in the Ava community focused on that right now. The areas we're primarily focused are on improving atomic commitments, extending. We have to release the actual NFT that has to get tested and get out, stuff on the AVM, expanding upon our asset creation stuff. Really looking at pen testing even more than we already have. And all these things, I think, are a higher priority than making Dogecoin run under Ava. But if you want to make Dogecoin under Ava, dude, do it. I'm down. I will give you anything you need to make that happen. Blockchain size be after 1 year? Who knows? So all right. You can't actually get an answer with that for Bitcoin or Ethereum or any of these other ones, because it really depends on exactly how much traffic is going through, and blocks are not necessarily blocks might have a fixed size or a gas limit, but they might not consume it all. With us, it's the same way. It really depends on the amount of transactions going through the network. Highball estimate average transaction size 250 bytes. It's a little on the high end, but it really depends on how much people are using this. One of the things that we're going to need to launch, and this will help us with our bootstrapping story as well, is because we do bootstrap just fine, but it'd be much better if we could get a very clean bootstrap that is a little lighter than what it is our pruning solution. State pruning is very important, because we don't need to give everybody the full validation scheme all the way up. You don't need that for Bitcoin. There's people who run archive nodes, bless their souls. They're great, but most people don't need that. So our pruning solution is very important to us. I think that you'll find, because of the nature of our finality and because of the way that things work, you don't need to have quite as much evidence chain as you do with like other blockchains. We're not producing empty blocks like ever. So I think also we don't necessarily have smart contracts built into every single type of transactions on the network. If you're trying to send Ava, you're not going to use the C chain. You can. It's just not the most efficient way. You'd probably use the AVM, which is a lot lighter. It's DAG based, and it would prune a lot better. So I would say that for us, the fact that the big threat here, I wouldn't call it a threat, is actually the advantage, but the big thing to look at is the number of transactions actually going through the network. And with a high number of transactions, it increases the size of the state history. It's just how it works. So I can't really say off the top of my head. I do think it's not going to be as big a deal as people might be concerned about, especially because pruning is going to be very effective with our system, where it's very difficult with other systems that bind consensus to the data structure of a blockchain. Talking about the consensus protocol, how you think a more local sampling would affect the scalability over the uniform sampling. Consensus protocol. I think more local sampling affect the scalability over the uniform sampling. I actually can't say. My advice is go with the uniform sampling. I really feel like you just sample from the validator network. If you mean local, as in like picking IP addresses which are more close to you, I don't think that's necessarily to anybody's advantage. But the gossip network will work the way it works, and it will get around, and there will be it will come to finality across the whole network. You could build something that locally, if you could geolocate, I guess, the IPs and stuff. I don't know if that's worth it, especially considering you're talking about fractional seconds of saved time. And the transactions are all parallelizable anyway. So I don't really think that's something I would endorse, at least not initially. Maybe later we can look into things like that. But right now I don't see that as being what you want to do. It also kind of breaks protocol a little bit. All of our assumptions are surrounding the uniform sampling of validators. So we'd have to kind of look into what effect that could possibly have on the overall consensus if people did that. It might be considered Byzantine even. I'm not sure. Thank you very much for the info and the info. No problem, Brad McFall. I'm glad you came. Do you guys have any other questions? I can go over a little bit if you like. Developer Accelerator prototype is running 1 week now. What's the input yet? The input is people are still trying to get their heads around our code. A lot of the response we've got is people trying to figure out how we've constructed things. The input on the code itself has been extremely positive. A lot of big names have looked at our code and were kind of like, this is really clean. Like, I can understand this, and your interfaces are all, non-specific and very generic and really decoupled. It's really just good as far as that goes. So we've had a lot of positive feedback on the code, and you can thank a lot of that to Stephen Butoff. He is an amazing developer. He worked on our he's the one working on the primary implementer for Gecko, and he's a really good work. He's amazing. So from the code perspective, it's been pretty good. Everything everything I've seen so far has been people just trying to understand. We're going to let this program run for a little while and see where it goes. Definitely through at least the Cascade test network, which we're going to be launching in April. But I don't. I haven't really seen anything that was kind of a strong indicator that people have found a lot of problems with our system yet, which is kind of the intent of the DApp program. So they've got a lot of time to get their head around what we're doing and really dig deep into the process of how we're building what we're building before they could find the primary bugs that are in there. And yeah, there are 4 bugs, guys. Four bugs are in this code that we know of. And 3 of them we consider to be extremely critical. So find them. They're out there. I think that this is something that we literally injected into the code so that somebody could find it. So there's nothing to find. We know that for certain. Cool. How big is the team right now working on Ava? Well, that's a loaded question. So it's not really loaded. It's just that we have a lot of people in different roles. So Stephen and Dan and myself have been primarily focused on the platform Gecko Client. I've moved on to Slopes recently. I did a Vash. I also worked on Gecko. Did the earliest versions of the APIs until the most recent version, and then Dan took over and scaled that out while I worked on Slopes and tooling. Stephen has primarily been working on consensus of platform and things like atomic commitments. So he's been doing a lot of deep work there. We have Kevin always does the math, anything that needs to be proven. We have that. We have an economist, Amani Moyne. She does a lot of the economics work. We have let's see. Amre Avawings in Discord. He is our front end guy. He designed everything you see, as well as some stuff that you haven't quite seen yet. But hopefully we can talk about soon because it's going to be super cool. We have Michael working on a special project. We have Ted Yin. He's also involved with the Gecko Client. He's been doing a lot of the EVM work you've seen. He's also working on Cedrus, which is an announced database upgrade that we have. It's a whole new custom kind of like level DB replacement that's built targeted for writes over reads. We of course Goon is architecting. So he's been doing a lot of that work. So it's really hard to say who's working on it. But I would say that, and we have like Chevavir, we have a lot of really, really great, brilliant minds on this system. And we had some people who came in, did some work, and then moved on to do their own thing, like pursue their PhD further. Or get more involved with another organization who is basically was already employing them. So we've had a lot of people. That was actually not very many. So I'd say we got a team of, let's say, 10 maybe strong developers in-house in Ava Labs. We have a growing team of people outside of Ava Labs working on our systems. And we have, a significant amount of people working to spread the word and get the vibe out so people can understand what's going on here and actually have nowhere to go to get the answers that they're looking for. How is the current corona situation affecting you? I'm fine. I'm just in my apartment. Thank you for asking, though. So our development hasn't stopped or halted or anything. We're still going full speed. We have not had anybody come down with major sickness. We've had nobody internally linked to the coronavirus that I know of. We are just running at full speed, pell-mell, like we have been the whole time. We are working from home now, though, which kind of sucks because we can't whiteboard as much. But we are still going full speed ahead on all production and are a little bit ahead of target, to be honest with you, on some of the deliverables we outlined in the roadmap. Of course, the way development is, one thing can trip you up and you go, oh, geez, that's going to be an extra week of work. But we have not run into that. A lot of the things we've promised, we are actually that aren't quite in yet. They're already done. So we're doing great. I'm very excited about this. It's not like a lot of disruption has happened as a result of Corona. If anything, I think people have time to hunker down and focus more on the deep work rather than getting sidetracked by every whiteboard conversation that comes their way. But then we don't have the whiteboard, which sucks. So yeah, we're fine. Did we prep enough toilet paper? So we work in a co-working space in Brooklyn called the Brass Factory. Beautiful co-working space. Tons of toilet paper. So we are good to go. And I live a block away from the Brass Factory now. So I'm literally a block away. If I run out of toilet paper, I will just steal from them and pay them back later. But no, we're actually fine. I went ahead and bought a few extra rolls before everything happened. So yeah, no, we're doing great. We have been joking about using certain white papers as toilet paper if we need to, though. Okay, not ours. So yeah, I love this. Thank you guys for participating in this. Is there any other questions? Something more technical? I do want to show off. I didn't do this the last time. There's a documents page that is really interesting and has our papers on it. So if you want to read some of the platform documentation, hop into the Developers Lounge on Discord. It's right there. Here's all of our consensus papers, all available on our website. And then if you would like to go through any of these tutorials, they're all currently available on our Medium page right here. And I really highly encourage everybody to join our Discord. Like, join the Discord. Hop in the Discord. We're there. We're talking to you. We'll get you through it. We'll get you up and running. We'll explain the most detailed aspect of the consensus that you want. We're completely an open book. Please come in there. Chat us up. Say hello. Introduce yourself. Get involved. We want you there. Cool. All right. Well, if that is it, we'll publish video on YouTube. I don't know what platform we'll publish this on. I know that Crowdcast does publish this video live. So we should be, there will be a copy of this video available to you all after it kind of compiles and gets ready to go. But yeah, no, this will be live and available and you can watch the whole thing. Cool. All right, guys. Thank you much. Appreciate you coming and listening to me yabber on for a while. If you have any other questions, again, hit me up in Discord. So I'll see you later. Collin Cusce, signing out.